Okay, so unit number 5, section 1 here, absolute value functions. So what we're going to end up seeing here is just like different equations. So we started off with our lines. So everything was like graph a line, graph a line. And then we started getting into graphing the inequalities, which we're still using lines. But now we're getting into graphing what our absolute value functions look like. So an absolute value function, all right, going back to unit 1, it has two possible answers. Therefore, when we're graphing an absolute value function, you're going to have two strands of the graph. So this we'll refer to as a vertex, which is going to kind of be like that center point that's there where the two strands go off from. And then an axis of symmetry. So this line, this imaginary line down the middle, that's going to separate them into two equal parts. So when we're talking about your vertex here, your vertex is kind of like the starting point. It's where the two meet at. So we can say starting point, all right? We can also say it's where the two, when we say strands, they kind of look like rays, all right? And it's where they are going to meet at. Whereas your axis of symmetry, this ends up dividing the graph, so dividing it into two equal parts. All right, so let's get into this here. So we're graphing here, and we're just graphing just our very much our straightforward, hey, y equals the absolute value of x. So when we look at this here, all right, when we kind of construct our table, so we got an x and we've got a y, and we're just going to choose numbers here. Now, what numbers are we going to choose? Well, because this is referred to as our parent graph, it's just a plain old x. It starts at 0, kind of like the 0, 0, you know, the origin that's there. But then we're going to have things that go to the left and go to the right. So regarding your x coordinates, we're going to go to the left 2 spots. We're going to go to the right 2 spots. And then we're just going to plug things in because there's nothing going on here. So plugged in for x, the absolute value of -2 is a 2. The absolute value of -1 is a 1. All right, 0, yeah, 1. And then absolute value of 2 is a 2. So now we've got our points that we can plot. So we talked about that 0, 0 because that is going to be our vertex. And you'll see it based on how we're graphing our points. So -2 up 2, -1 up 1, +1, +1, +2, +2. And if we started doing more of the table, what you're going to end up seeing is they're going to hit and make this nice V. So we talk about extending our lines. Well, yeah, we're doing the same thing here. So you can kind of see how it's arrayed because it's got that starting point. Oh, I don't like what I did there. All right. But it also, it's where those two rays meet at, and they happen to meet at the origin. So again, this is our parent graph. Everything based off of our absolute values. We'll move on this. So your vertex that's there, it is at the order pair 0, 0. The axis of symmetry. Now, the axis of symmetry is always the x coordinate of the vertex because it's what goes right down to the middle. So we use a dotted line. That's the way when we graph things, we're like, it's kind of imaginary. It's not there. We can't land on it. Does this have a maximum or a minimum? Well, the vertex is always going to be the maximum and minimum. In this case, it's a minimum because it's the lowest point on the graph. Everything else is above it. Your domain, well, we keep going to the left to -infinity. We keep going to the right to positive infinity. The range, how low does our graph go? Well, it hits at 0. That's why we have the brackets. And then it keeps going up. So it goes to infinity. So there we go. Regarding transformations, there's none. Again, this is what we call the parent graph. It's the most basic absolute value equation we can do because there's nothing done to it. It's just an x that's there. So let's start playing with it so you can start to see what's going on with these particular items. go back. Let's go back to problem number 2. This is a good one. That's here we kind of look at it. So when it comes to making our graph here, we're going to always use 0, 0 to get started, unless things move from left to right. Now, if we kind of go back up to what we saw in previous units, who moves things from left to right? Well, yes, it's that guy. And remember, it's the opposite of it. That's why it's got that minus h that's there. So if we go back down to the problem that we're in and we go inside there, there's no one moving it left to right, so we're going to stay right there. So that lets me know is, hey, I can still choose my -1, my -2, my 1, and my 2. Now, this is your x, this is your y. Because the person inside controls the left or right, and there's nothing going on here, we leave it alone. But now that we've got this +1, it's going to end up moving our graph up 1. So what we're going to do is we're going to get the original points first, and then we're going to start moving things around. So we're focusing just on that parent graph. So when you think about it, your parent graph for your absolute values is always going to be this. Always. Which means it's always going to be a 2. It's always going to be a 1. It's always going to be a 1. It's always going to be a 2. Always, always, always. So because that guy right here moves it up or down, that's why we're going to add 1 onto the y's, because the y ends up moving up and down. So we just added onto it there. So that's a 3, that's a 2, that's a 1. Again, we're just adding 1 plus 1, that's a 2, 2 plus 1, that's a 3. So what we have now here is our new ordered pair. We're going to use our x coordinates because we didn't move it left to right. We're going to use our y coordinates here because we did move it up 1. So we're going to graph the ordered pair -2, +3. So -2, +3, boom. -1, +2, -1, +2. 0, 1, all right. 1, 2, to the right 1, up 2, to the right 2, and then up 3. So what you can see here is we have the exact same graph, that V shape, but it's been moved up 1. That's it. So let's look a little bit more here. Well, looking at problem 3, can you get an idea what's going to happen here? Yeah, we're inside, we're going to do the opposite. So it's a +1, but we're actually going to move it to the left 1. So parent graph, that's here. So again, automatic, that's there. The x, the y. We're always going to end up choosing these points when it comes to absolute value. And the absolute value of -2 is always 2. The absolute, remember, we're using the parent graph here. So that's what we're working off of. The absolute value is 1, is 0, 1. Again, it's automatic. When it's absolute value, boom, throw that down. Nothing's going to change until we start digging in. Now what we can see here is we're messing with the x, which shifts the left or right. So we're going to focus on this x that's here. So +1, we're actually going to subtract 1 each time because, again, it's the opposite. So if you're at a -2 and you take away 1, you're at a -3. If you're at a -1, you take away 1, you're at a -2. You're at a 0, you take away 1, -1. You're at a 1, you take away a 1, you get a 0. You're at a 2, you take away a 1, and you get a 1 that's there. No one's moving it up or down, so I'm going to be using this, and I'm going to be using this to graph. Watch what happens. So the ordered pair -3, 1, 2, 3, up 2. The ordered pair -2, 1. The ordered pair -1, 0. The ordered pair 0, 1. Yeah, do you see what happened here? Yep, 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 yep. There we go. It's the exact same graph, but has shifted to the left 1 spot. Didn't go up like the previous one there. So when we're talking vertex, and I know we didn't do this on the other problem, we're talking vertex, we're talking the order pair -1, 0. All right, boom, right there. Axis of symmetry. Well, as you can see here, if I draw my dotted line, you can see we're 1 away, we're 1 away, we're 2 away, we're 2 away, that's there. So my axis of symmetry is going to be at a x equals a -1. Max or minimum, it's got a minimum because remember it bottoms out. The domain, still the same thing. We're going negative infinity to infinity, and my goodness, people, that's not going to change with any of our absolute values. Your range, how low does it go? Well, it did go as low as 0 and does go as high as infinity. That's there. Watch your brackets. And then transformation. So what do we end up doing? Well, we ended up going to the left 1. So again, we talked about transformations in the previous units. Now we're starting to see it. Okay, so let's look at someone like problem number 4. This one's going to kind of handle everything, and then this one will be our last one as well. All right, so automatic, x, y, -2, -1, 0, 1, and 2. Again, these are automatics because of our parent function. Absolute value, and again, this is what we're working off of, that very first graph that we did. Absolute value of -2 is always 2. It's always 1. It's always 0. It's always 1. It's always 2. So that's automatic. That's there. Now, we've got a lot of action going on here. First thing here is I look inside the parentheses. I see a -2. Remember, we do the opposite. So what that tells me is I'm going to add a 2 onto my x coordinates. Now, remember, that shifts it left to right, which is why we're playing with the x coordinates here, because that's the x-axis. So if I add a 2 on, I get a 0. If I add a 2 on, I get a +1. If I add the 2 on, I get a 2. If I get a 3, I get a 4. Now, over here, it's a 2-part series. It's what we call AY plus K, all right? So remember, this is the guy that's moving it up and down. That's my K, so we're going to add a 5 on. But this guy, remember, that's your stretching and your compressing. So we're actually going to compress the graph, which is why we're talking about the Y value here. So you're going to take 1/2, that's the A value, and you're going to multiply it by the Y term and then add 5 onto it. So we look at 2, half of 2, all right? So this is kind of what's going on here. We're doing this. Half of 2 is 1. 1 plus 5 is 6, okay? Plug in the 1. Half of 1, all right? Half of 1 is a half. A half plus 5, that's 5.5. 0, half of 0. Well, that's still 0. 0 plus 5 is a 5. And now the same thing's going to start happening on the other side because, again, we're plugging the 1 in again. So when we do this, there's really actually no reason to write it out because I know I'm going to get 5.5. Plug in the 2, I know I'm going to get my 6. Let's watch what happens to the graph. So I'm graphing U, my new x's, U, my new y's. So it's the order pair 0, 6. So 0, 6. There you are. The order pair 1, 5.5. Going to the right 1, going up 5.5. All right. 2, 5. Going to the right 2, going up to 5. 3, 5.5. There we go. There's that axis of symmetry here. We're the same distance away on both sides. And then I see a 4, 2. So I'm going to the right 4. I'm going, 4, 6. Going to the right 4, up 6. That's there. So let's let you in on something a little bit that's here. See this 1/2? It's kind of like the slope. Yeah, look, it's a half. You are rising 1, running 2, that's there. If you get the next kind of fit the pattern here, you're going to be there, rising 1, running 2. So, and there we are. So if we notice and go back to the very beginning of the problem here, all right, we've gone to the right 2. Take a look what the vertex is. It's gone from 0, it's gone to the right 2. Plus 5. Instead of being at 0, it's pushed up 5. So my vertex is at 2, 5. So I can actually get the vertex right off of this information right here. But I'm also seeing it in my graph as well. Let's look at other things that are going on here. It got compressed because of this 1/2. So now you're actually seeing the compression because, again, we did get smaller. We went from a 1, all right, the absolute value of x is at a 1, and we went to a 1/2. So it got smaller, so it looks like it got squished down. We'll see you later.